Assalamualaikum and selamat sejahtera to my lecturer and fellow friends. Today, me and my groupmate will be presenting Plaxis project as a part of Foundation Engineering course requirement. Our group consists of Oji Alfian bin Mulyanto, Mas Najira Betty Masli, and Natalie Elianis Knight. For this video presentation, the content consists of introduction, problem statement, material properties, model geometry, displacement contour, effective stress contour, factor of safety, and also conclusion. Next. As for your information, landslides are the major geologic concern. Each year, landslides cause billions of dollars in damage and result in hundreds of deaths and injuries. Some landslides move slowly, causing damage over time, while others move quickly, destroying property and taking life suddenly and unexpectedly. The force that propels landslide is usually gravity. Next. Heavy rains, erosions, and poor constructions methods are all factors that cause landslides. Landslides are often associated with severe rainfall and can worsen the impacts of flooding. Okay, for the problem statement. On Friday, 17 September, a landslide occurred in Jalan Kemensa Heights, Ampang. Unstable position, construction of impermeable swimming pool on the surface of or the existence of a river at the foot of the cliff are among the three early possibilities of landslide on Jalan Kemensa Heights. The increase in water in this area causes an increase in pore water compared to the surrounding soil, thus lowering the shear strength of the slope and potentially failing when reaching the failure threshold value. For this project, we took landslide as a geotechnical engineering problem. The location is located at Jalan 7 Kemensa Heights, Ampang. This problem will be solved by stabilizing the slope using Plaxis 2D version 8.2. Plaxis 2D analysis was utilized to predict the factor of safety for the location in the case of low water and high water level.
Next, we will go to the geometrical properties as shown in the table. So we have here for the undrained, the gamma not saturated is given by 16 and the saturated value is given by 18. So next we have the kg, kc, the ck, and all of this value will be then used to calculate the factor of safety in manual calculation.
So I will be presenting for my part. As for displacement control, it shows the movement of soil. And as you can see next, which is the total displacement. The first image is the contour lines and second is shadings. And as you can see, the bottom line, there is a blue color shades, and the blue color usually shows the deformed finite element model. Next is for the horizontal displacement. There is a huge blue shadings at the bottom, which shows there's a huge deformed finite element models. And lastly is a vertical displacement. And as you can see from the shadings at the second image, it shows that the deformed finite element is at the top in the middle and also at the bottom. As for effective stress contour, it is a stress that keep particles together. And as for soil, the stress is pore water pressure and also total stress. The first picture is effective stress, which shows the reciprocal direction, as you can see from the red lines. Next is the mean contour, and also relative shear contour. For this image, it shows the mean shadings. As for this image, it shows the relative shear shadings for the effective stress.
So for the manual calculation, the situation is depicted as given in the picture. So basically, this is just an illustration on what the condition at the site. So we have here the pile sheet wall, and this is the soil, the granular soil that we're going to retain, and this is the different layer of soil at the proper site. So basically, from the information and data we found out that the factor of safety through manual calculation is given by 0.269 for the pile sheet wall, and the value was calculated from this formula: Kp design is equal to Kp over Fs. So KP we get the value, KP design we get the value from 1.5 times by the theoretical depth of the firewall, and KP we use the formula of passive work pressure. So the value can be improved by adjusting the parameters. So we have some parameters here. We have the length of the sheet and etc. So we can adjust and get the desired factor of safety. Okay.
So for conclusion, it shows that for this project, we use Plaxis 2D software as a tool to analyze the deformation and stability of geotechnical engineering, specifically for the slope issues. And we also have done a manual calculation for that. From the analysis, you can see that the value of factor of safety from the Plaxis is 1.503, which we can conclude that the proposed filing for the solution is rather inadequate based on the problem that we have with the technical that we proposed earlier. Therefore, there are still few measures that are needed to overcome the safety issues in the future. Thank you.